Imagine the largest explosion ever recorded in the history of the universe. A star, hundreds of times bigger than our Sun, tears itself apart in a matter of seconds. Shockwaves rip outward at millions of miles per hour. Enough energy is released in that single moment to outshine an entire galaxy. And you would hear absolutely nothing. Not a distant rumble, not a faint echo. Nothing. Complete, total silence. But why? How can something that violent, that catastrophically enormous, produce no sound at all? The answer has nothing to do with distance. Even if you were close enough to see it with your naked eye, you still would not hear a single thing. That answer comes down to one of the most fundamental and most overlooked facts about how sound actually works. And once you understand it, you will never think about space the same way again. Here is something most people never stop to think about. Sound is not a thing. It is not a beam of energy shooting from one place to another. Sound is a disturbance, a pattern of pressure, molecules bumping into other molecules, passing that bump along over and over again, all the way to your ear. Strike a tuning fork. The metal vibrates. It pushes the air molecules next to it. Those molecules push the ones next to them. That chain reaction travels outward in every direction at roughly 343 meters per second. When it reaches your eardrum, you hear a tone. Take away the air, take away the molecules, and that chain reaction has nothing to carry it. The vibration starts, and then it simply stops. There is nowhere for it to go. This is the key thing. Sound does not travel through emptiness. It travels through matter, and space, it turns out, is about as empty as anything can possibly get. When we say space is a vacuum, most people picture something like the inside of a vacuum-sealed bag. Mostly empty, but not completely. The reality is far more extreme than that. Here on Earth, every cubic centimeter of air you breathe contains roughly 27 million trillion molecules. That is a number so large it is almost meaningless. But it gives sound plenty to work with. Now travel upward. At the edge of our atmosphere, around 100 kilometers up, that number has already dropped by a factor of millions. Higher still, and you cross into what we call outer space. In the interstellar medium, the space between star systems, there are roughly 1 to a few atoms per cubic centimeter. 1 atom, in the space the size of a sugar cube. And in the deepest voids between galaxy clusters, it gets even thinner than that. Try to pass a sound wave through 1 atom per cubic centimeter. There is no chain, no relay. The disturbance has nothing to push against. The silence of space is not like the silence of a quiet room. It is not like the silence after midnight in the countryside. It is a silence so absolute that it exists on a completely different level from anything we experience on Earth. Back to that exploding star. A supernova releases more energy in its first few seconds than our Sun will release across its entire 10 billion year lifetime. The outer layers of the star are blasted outward at speeds of up to 30,000 kilometers per second. Physically, mechanically, everything needed to make an enormous sound is happening. There is pressure. There is violent motion. There is shockwave energy propagating outward. But in the near-total vacuum surrounding the star, those shockwaves cannot sustain themselves as sound. The particles are too far apart to pass the disturbance along in any meaningful, continuous way. What you would experience, floating nearby, is nothing, a blinding flash of light, because light does not need a medium to travel. Intense radiation, same reason. But sound, zero. It is one of the most counterintuitive things in all of physics. The universe produces violence on scales we cannot comprehend, and does it in complete silence. Here is where it gets interesting. Sound, strictly defined, cannot travel through a vacuum. That part is true. But space is not always a perfect vacuum, and in places where matter is dense enough, something very much like sound can and does occur. Inside stars, for example. The interior of our Sun is a churning, boiling plasma, an almost unimaginably dense soup of charged particles. Sound waves propagate through it constantly. Scientists actually study these waves to understand what is happening deep inside the Sun, in a field called helioseismology. There are also vast clouds of gas and dust between star systems, nebulae. These clouds are still extraordinarily thin by any Earth standard, but they are dense enough that pressure waves, sound waves in the very loosest sense, can move through them, extremely slowly, at wavelengths so long you could never hear them. But they exist. In 2003, astronomers detected what they described as a note, a B-flat, resonating through the gas surrounding a black hole at the center of the Perseus galaxy cluster. The wavelength was approximately 30,000 light-years. That is not a sound any human ear could ever perceive, but by the physics of wave propagation, it qualifies. So the universe is not entirely silent. It hums in registers so deep and so vast they exist outside any human scale of experience. Picture yourself in a spacesuit, floating in open space, far from any planet, far from any significant source of radiation. You look around, stars in every direction, you are surrounded by the universe, and you hear nothing from outside. But here is the strange part: you are not in silence. Inside your suit, you hear the hum of your life support systems, the sound of your own breathing, your heartbeat. Because you are full of matter, fluid, tissue, bone, and sound travels through you just fine. If you touched your helmet against the hull of a spacecraft, you would hear creaks and vibrations conducted through the metal directly into your skull. Sound travels through solids and liquids very efficiently. The silence is not inside you, it is the space between things. And in a strange way, that is what makes space so psychologically vast. It is not just that it is big, it is that it is disconnected. Every object out there, every star, every planet, every explosion, exists in a kind of isolation that nothing on Earth can match. When we watch space documentaries, this one included, we add sound. Whooshes, deep bass rumbles, dramatic audio landscapes, and that is fine. It helps us feel the scale. It triggers something emotional in us. But it is worth pausing for a moment and sitting with the reality. The universe is 13.8 billion years old. In that time, stars have been born and destroyed by the billions. Galaxies have collided and merged over hundreds of millions of years. Black holes have consumed entire star systems. All of it, every single event, happened in silence. Not metaphorical silence, not artistic silence. Literal physical silence, because the medium needed to carry sound simply is not there. There is something almost philosophical about that. We tend to imagine cosmic events as loud. Our brains were built to associate scale and violence with noise. But the universe does not share our instincts. It is vast, ancient, violent, and completely, utterly quiet. So, why is space completely silent? Because sound is not a thing that travels on its own. It is a chain reaction, molecule to molecule, particle to particle, and in the near-perfect vacuum of space, that chain has almost nothing to work with. The silence of space is not an absence of events. The universe is full of events. It is an absence of medium. A gap so profound that even the most violent forces in existence cannot bridge it with something as simple as a sound wave. The universe has been exploding, colliding and burning for almost 14 billion years. And it has done every last bit of it without making a sound. If you found that worth thinking about, subscribe. There is a lot more where that came from. Next time, we are asking a question that goes even further back. Before the Big Bang, before space, before time, before anything, what was there? And does that question even make sense to ask?